Welcome, I'm Bill Wake. We're here working on a tool to help you analyze your finances. And part of the tool that we want to use is we have the notion that you have these streams of income or outgo, and eventually we'll have assets and liabilities as pools or blobs of money. But we'd like to be able to make a tree structure because we want to examine alternatives. So we're using something called an and or tree where every node if it's an interior node, it either says, I need all my children or I need exactly one of my children. So to do that, we need to convert to a tree structure. We tried some yesterday and it didn't end up working too well. We thought we had it working on the data structure side or the production side, the logic side, but we don't have it working on the UI side. All right, now I did do one thing offline. We had created two separate views. One was the original view, and one was the new view that we're trying to implement. And in the previous incarnation, they each had access to the is presented sheet flag or something like that. I made that separate for each one because they really are their own view as far as when they add things and so on. All right, now let's run it. Well, yeah, let's run it. I'm sure someday I'll start it before I get logged in here, but not today. Okay, and then I've got to say, I looked at the code again. Let's see. Well, plan. One thing I noticed was we had done this as sort of a parallel change and relied on the existing plan tests, but I think the structure of this thing is, well, I don't think that test was adequate for it. And I don't know, because, well, let's see. Are you coming? Come on. Well, what I think we saw yesterday was if you added a new node, it showed up in the original formulation, which was built around a list of streams, but it doesn't show up in the top section, which is our new section. So I'll create something. Here's salary. Notice it didn't go away the first time like it did before. That was that flag. Okay, so let's make $300, month 2 through 33. Okay, now I create this. It shows in the original view as one of our streams of input. It shows here, we can tell it's been accumulating stuff, but it doesn't show in here. Okay, and that makes me pretty suspicious. So I'm, Well, what it's saying to me is we don't seem to be adding the child to the thing we're viewing. And I don't know. When I look at this code, I mean, it's got this recursive structure to it. You've got streams that are the leaves, and then required, which is the and part of a tree, contains an optional list of children. So it forms a tree. It's a recursive structure, we call it, with indirect. But the thing I'm not so sure about, well, what I'm suspicious of is this mutating function. It's legal. I mean, it compiles, but I wonder if it's doing the right thing. So I think what we'll do is let's focus on the test side. Well, is that even right? I don't know. No, I think what we should do is focus on the add. Let's set a breakpoint here. Let's find our tests. A plan. And if you recall, we're trying out Jeff Langer's test naming convention. So tests start with a or an or some. All right, so we add a stream to the plan and check that the data that it produces is correct. Yeah, okay. I mean, it, well, this is not a lot of tests, is it? It's probably enough for lists, but I don't think it's enough for a tree. All right, let's see if this is, let's just run this test. So we add, I mean, the real thing is we'll add a stream to our plan and let's monitor what's happening here. Because who stores the, who opens the sheet? They're supposed to be sharing the same model. Let's look at that for a bit. So streams is the old model and plan contents is the new one. Well, actually contents is because we want the top level entry is going to be the category name. So that'll be an array of plan twos. But in some sense, this is the one, the new sheet, the old sheet used. And actually, we when we create, we're calling add. So we've built a stream, which is the sort of leaf of our tree or the list element. And then we're appending it in both. So that's the parallel nature. So we append it to the list and then we add it to the stream. We add it to the plan contents. All right. And the plan contents is we've got this mutating function here. And he says, if you're a stream, well, it doesn't make sense to add a stream because you should be a required because only requireds get lists of stuff. All right. And once you have it, we allocate a plan, append it to the stream, and basically rebuild our node. So instead of name and the original plan, it's name and the new plan with the value appended. All right, let's see. We are stopped down here. Okay, so let's look at stream. All right, so we got an edit salary with 1,000. Oh, our test uses defaults first and last. Okay, and then let's look at streams. We haven't appended anything yet, so this should be an empty list someday. No, the UI uses it's still using the plan structure. Okay, so let's find content view. Yeah. Okay, so in here we're getting a binding to the same plan that we're calling on list view and list view original. They're both monitoring the same plan object. And so it doesn't matter who owns the plus sign thing. It should be irrelevant. Now, is that true? Yeah, because it's the same plan. So even if whichever one adds the thing, it's clearly showing up in the second one. Well, it has no knowledge of any separate thing. It just looks at the original list of stream version when you're examining the contents. Okay, so let's go down to this list stream list original. Right, so he walks through plans.streams. All right, so that's the old way of looking at things. All right, now, and he does a stream view on each one. Yeah, that seems okay. All right, so there's streams, yes, empty. And let's look at plan contents. All right, yeah, so I renamed it to your finances. Maybe my finances would be better. That's the top level node, and he has no values in him. Okay, so a required has a name and a list of values, and right now it's empty. Okay, so what should happen? Plan. Yeah, so let's step over. Take. Okay, well, let's step over both. Let's look at streams again. All right, it should have one thing in it now, the $1,000 a month thing. Okay, and then let's look at plan contents. I don't know why my debugger, I don't know, it seems very unresponsive. Okay, yeah, it has 0 values. So something is wrong in the mutation. This isn't working, in other words. Okay. And I wonder, and I poked around a little on the internet too. I'm thinking it may not be, well, this mutating thing, what we end up doing is replacing self with the new value. But I don't know if that self, like if you're in a tree and we're replacing the list of children, if we modify the list of children, it replaces the self, but does it replace the actual array in the tree? And that I'm wondering about. All right, so let's continue. All right, UI doesn't use the new data structure. Yeah. Okay, so well, I don't know why that's running like that. Actually, we have no UI tests. I'm not sure why that stays up. But anyway, let's run our test again. Same test. Okay, and this time let's step into our mutating add. Okay. A plan, run this test, creates a $1,000 salary forever. Good work if you can get it. All right, so I'm going to step over and I'll just continue from here because we'll stop at plancontents.add. Okay, so we've got a stream. Let's make sure it's the one we expect. Yep, there's really no other stream involved. Okay, and we do an add. Well, let's print self. Okay, that's our plan contents. All right, so we'll step over. Not a stream. It is required. Let's print name. Should be your fine. Wait a minute. Oh, that's the existing. Yeah. Okay. And print plan. It's the array. No values. Okay. So if we step and step, all right, let's look at new plan. Okay. Yeah. So new plan modifies that plan to be a list of 1 value. So this is this is what we want. Okay. Now I'm going to step over again. And I don't know if I can see self at this point. Yeah. Okay. All right. So, I mean, this is what I expected or / hoped would happen. The value we passed in gets added to the finances at the top level. All right. Now I'm going to step again. All right. And we're coming back. Let's look at plan contents. Yeah, that's what we saw before. We got back from this thing. We supposedly had updated it. The update looks good, but it doesn't seem right. It didn't seem to take. Okay, now we're fully past it. If there was a missing assignment or something, no. Okay, sucks. Oh. Okay. let's go back to that example, this thing. You know, okay, they used a struct. Is that going to matter? Because I notice they're initializing it. It's treated as a read-only structure in this example. So is that, well, does a struct have the same problem? If I provided a mutating function add, would it do that? Well, what I'm taking away is enum does not let me write that function I want because it doesn't keep the value after it assigns it. I mean, they are kind of a value type, but meaning they're treated as simple values like an int. They're not treated as pointers to something. And so in some sense they're immutable. Structs are immutable, but in another sense they're not. There's this goofy mismatch. By default, they're immutable, but if you can define a function, tag it as mutating, it's supposed to mutate. And then the compiler worries about how do I make sure the new value shows up. Now, what I'm seeing is the new value is not showing up in my enum, which is a very similar structure. Right. So let's, yeah. I mean, this is the kind of thing that happens when you have things and they don't get reassigned, and I think because they're basically read-only, it just doesn't happen. All right. But I think what I'd like to do, and this may be, well, I want to throw in a test for plan 2. Okay. So we've found something suspicious. Let's make a plan 2 test. I'll leave it on here. We'll clean up later, but let's test modify plan 2. Okay. So let's let plan equal plan 2 dot required my plan and an empty array. Okay, so plan, well, let's split the screen here. Okay, plan, a plan. Okay, so required requires these two fields, and then we wanted to say let's stream equal, and we'll just kind of steal this. I'll make it 500 just so it's a little different. Okay, so there's our stream. Now the focus of our test is plan.add stream. And the assertion is whoops. If I take if I take plan dot, and I think we allow you to ask for children, right? Yeah, so children sub 0 should exist, and its name should be salary. Okay. value of optional plan 2. Right. So if our addition takes, then this array will not be empty. It'll have a child sub 0. And because it could be empty, it's optional. So I have to do a bang or something to get there. Okay. But that should be salary. All right. I think this test is going to fail, which really kind of sucks. Okay. Now I'm puzzled. All right, let's look at this again. So that seems to have worked. Where am I looking? The mutated. Okay. Sorry, where's my test? Now, what is the difference? All right, let's make var plans. It contains plan. Let's reference this, that. Trying to make it more similar to our situation. But I don't see why that should be any worse. I guess unless plan sub 0 doesn't update. No, it does. What? Okay, I'm going to make it even harder. All right, so I got a stream. Oh, this is not, is that right? Add stream appends dot stream of stream. Wait a minute. So plan sub 0 sub children sub 0 should be a plan. Oh, and we ask name. We made name able to answer it from either side. Okay. That's awfully similar. Well, how can I make this? Well, that's working off data last. I mean, I would really like to know, is this plan in the project? Sorry, is this stream in the plan? So Well, let's put another level in. Make this the top plan, and its contents are plan. Okay. And now plan sub 0. I think I have children, right? Add. Cannot add. Children is a get only property. Well, that's a good rule in general, but I mean, that was intentional because I want the list of I don't want people modifying the children on me. I'm the plan. I get to control what happens to it. No, let's do plan.add stream. Okay, so I think that's going to modify plan, but we would hope that plan from plan 2 gets it. So plan sub children sub 0 should be my plan. This should fail now because I think it should be my plan. And then we'll go another level in and get the field that it should be. Boom, plan sub 0. Oh. Plans equals plan container. Good. And this should be my plan. Right. Okay. That's what I expect. All right. And then if I look, plan sub 0, so children sub 0 dot children bang sub 0 name should be salary. Okay. Because I'm trying to change something 2 levels down. All right. Okay. Current plans. Plan sub 0 is top plan. Plan sub 0 dot children sub 0. Oh yeah, that's right there. It did not add. It can't add to the middle of a tree. It can deal with it can change the top level, but it can't go in the middle of an enum that's got a big tree and you change something here. It doesn't realize it should totally throw away that and put this new piece in and somehow notify everybody that listened for it that this is no longer trusted, or it's changed, I should say. Nothing trusting about it. I believe this is demonstrating the problem. Okay. Ugh. All right, now what's the solution? Well, let's go back to Spike View. I can close this. All right, now I changed this from enum. Do I still have this? Category equals tree of string. Right. Let's take the articles example now. Okay, so I'm going to define this. The experiment I want to run is what happens if I change this to a struct type. Okay, and I think it'll be easiest to just take this code. One more prog. Okay. That's fine. And then we're doing the outline group in a list. So I think that was near the end. Yeah, I think that's this. Okay, this should get us back to a viewable thing. Yeah, I don't know. Yeah, that's doing the update manually. So what I want to do is go back to the struct, see if we can modify the struct, kind of do the same test, only on the tree struct, and see if you can modify a deep child in the tree in the struct. If you can't, we'll move it to a class because I know you can modify contents of classes. But the update, it's all going to come down to the observable. See, the good thing about doing it as a struct is if that value changes, the notification mechanism knows that a value changing on a class is caused to do an update. Request an update visibly. Okay, so this is working. All right, and let's kind of do the same test. On tree. Let's make a function, make categories. I'm gonna do a manual test. It yields a tree. Tree of, array of tree string. Yeah, I need a body. Okay, I think that should work the same. Yeah, now does it work? Well, you don't know who your parents are when you change this. You're just pointing at a node and saying change this node. So it would require some real deep work, I think. But okay, we have the same thing back. All right, now I'm going to make categories, change it. It's going to take, let's make this so far. Okay, so if I take category sub 0, I have a tree. And if I take children sub 0, no, if I take category sub 0, and I add a child. Okay. Category sub 0. Okay, is that? Cannot convert return expression. Oh. Cannot convert value of string to expected argument type tree of string. I guess I need to make it into a value. This should be tree value colon old. Member on immutable value categories is immutable. Optional type tree string bang. Okay. I don't see why categories. Okay, I guess it's not a problem. This will add to the top level, then we'll try doing it a level down. Okay, good. That one. Right, so new tree. Well, let's make this new leaf equals tree, and then new tree is do that. Okay, but now, so if I append new tree, is there an append? I want to make it slot 0. Insert at. Insert element at index. Do they named? This one is. Okay, so I'm creating a new empty tree called new tree, and I'm sticking that in as the first child in front of hoodies. Okay, and then category children bang sub 0 dot insert new leaf. Well, this can be append. Children sub-0 should get me this new tree. And get its children. So that should get me from the categories to the new tree to the list of children to which I append. There's new tree, and he's got the thing in it. Okay, so this is kind of the equivalent of our test, and it appears to be working, that we can modify 2 levels down and the whole thing reflects it and it's updated properly. So that's a good thing. Okay, so what's the way to get this going then? We got a plan and plan. Okay, I'm going to take this test out. Okay, so I guess we're only treating it as a list of things. I'm gonna muck with this indirect enum. So for us, the leaf is the stream is the leaf. Okay, so by analogy here, this is going to be a stream. That doesn't seem right. Because an interior node doesn't have a stream. It makes me want to go right to the class solution, and I just don't know if that's going to be helpful. Yeah, because we want interior nodes to have a string and leaf nodes to have a string and a stream, or a stream contains a string. But this does not reflect that. Well, that suggests I'm going to take this to... Okay, have I broken anything at this point? Let's make sure. I've got a couple changes. Okay, let's commit update before trying a different approach. So the approach I'm thinking of, yeah, because the structs, they want the trees, they want it to be homogeneous all the way down with the values inside. We don't. And so I think we're going to do more of a composite. I mean, I kind of always knew it as a tree, but a composite. So let's make protocol. I don't think we need everything in the at the top. Yeah, so I guess in our case, we need a let name be of type string and let children be of type optional plan3. So I'm doing another parallel implementation and we'll take out the stream one. Can require properties to be immutable. Right. Get and set. I don't know if that's needed or not. Okay. So if we have this, and then I'm sorry, class leaf is a plan3, and it's got a stream. Okay, it takes a stream. All right, and then it has to, better take it needs a name. Var name of string is really stream.name. We can decide later how to pull those out. And what does it need? Children? I'm not sure about that any. Var children. Well, this is a leaf. So let's make these optional. A leaf's going to return nil. Okay, so yeah, I don't think we can just add the leaf in the struct form. Okay, why does not conform? Var children of plan3 type. And that looks like a getter to me. Putting any in there seems like it's going to screw things up. But I haven't used any very much. Does not conform. Add stubs. Maybe I just have the get, not the set. Maybe, okay, it doesn't complain. All right. And then class. I don't know. I want to call it everything plan. um, maybe this is plan leaf, and then plan composite also implements PlanTree. Okay. Does not conform and stubs. Okay. All right, we need an it. Okay, well, that hangs together so far. I don't know if... I kind of want to do this. You can look at the children. You can append PlanTree. Right? And then this now can just go back to being nil. And this becomes the function. And I'm saying ignore it. Okay. And this is a common thing with composite. It's like you're trying to make it so you can treat the leaf just like the composite, you know, the interior and exterior nodes the same as much as you can. But you have this, I think they refer to it as like sort of a safety transparency trade-off. If I try and make everything so clear that you can, you know, you can't append to a leaf as part of the interface in the protocol, you know, then I wouldn't even bother putting append or children in there on the protocol. I would just have name, and then you'd have to cast it in and decide, is this thing a leaf or a not leaf, and do all that. Now, I mean, that's exactly the kind of decisions the enums did too. All right, so I don't know. We need an append. Our private set, I think. Append plan of PlanTree. And now we do children.append PlanTree. Okay. Whoops. Can I find children in scope? Well, this should be plan. I'll give you that. Okay. Expected pattern does not conform. An optional plan value in plan 3. Well, let me put the name on top. We had the leaf when needed. Yeah, we're going to have to do something funny. Okay, and var this, well, let's do private var my children of plan 3. And then I need to get our children of plan 3 optional. Get return my children. Is that kind of to it? Okay. I feel like I'm still leaving a hole somewhere on append. No exact patch. Yeah. Okay. This is too much like coding. I'm gonna have to backfill tasks at least. All right, but the deal is, if children is an empty, then you can't append to it. So, they'll do something else to append. Okay. Children equals array of plan. Okay, because it's optional, it starts out empty. My children. Okay. If it's empty, it starts out there. Now, why is that? No exact match isn't called to it. I guess to be consistent, I'll do this. Now, okay, so create a new array with plan appended to it, or take the existing array and append plan if it already has children. Okay. Yeah, so compare that to this, right? I mean, this was much more straightforward of a solution. And we don't know if this one's going to work yet either. Okay, so I don't think we have to worry about plan 2. Let's take out this, and now we'll put an array of plan 3s. All right, and well, we want plan contents is well, it's going to have to be a plan composite of name my finances. Okay, so that gives us a starting composite in place. Then plan contents dot, well, I think we called it append, right? Yeah. Okay. Well, plan contents has no member net. not form two. Oh, so this is plan leaf of stream. Okay, and then this was trying to get it. Oh no. Cannot call value. Plan contents dot append. Make sure I got it up in there. Okay, I call append on a plan 3. Plan leaf takes a stream. Not sure the complaint. Cannot call value of not. Oh, yeah, it's plan leaf. Okay. All right, now net. All right, that's a legit thing. So the function for this needs to move up into the parent, into plan 3. Okay, so question we're going to ask things is, what's your net on this month? And a leaf is just going to return the streams value. All right, and we can see that in here. Well, we know it's a stream, so I think stream has its own net, right? Stream dot net, no. Stream dot monthly amount. Okay, so whatever the stream is for that month, that's the net. And then this is, well, we need the same function definition. And I'm really going on a limb here, test-wise. Okay, wrong type of print. All right, so this is guard if children is nil. Or no, guard let children equal children, or is it my children? That's probably okay. Else return $0. If I have no children at all, return 0. Otherwise, I think I can just return, well, the sum. What do we do down here? Do we do a reduce? Yeah. Okay, so something like this. Well, it's children. Oh, took care of that. Okay, children reduce dollar result plus item net. That seems like slightly harder than I want, but okay. All right. So now our view. All right. So the test should run. I don't think they can tell any difference. And that's a risk with parallel change, because the intent is at the end we plug in the new thing and all the existing tests are good. And they should be passing, there's nothing against that. But in this case, we're replacing a list with a tree, and a tree has more to it. And in fact, we're going to use the greater capability, but so this stuff I'm doing gets beyond what the list would ever, what treating it as a list would do. And given that, it means that our tests really aren't enough to cover its actual behavior. And if we start doing things that rely on the sort of extended behavior beyond list nature, because you can treat a tree as a list, but you can't treat a list as a tree. So if we use it as a list now, it's fine. But as soon as we do anything tree-like, or the more tree-like stuff we do, the more we haven't tested what the real behavior is going to be. Okay, well, these tests pass. Let's run it. Now, we haven't done a new view based on this new class. I'm still running my spike. All right, so we have the two views, but the top one is just wrong. All right, so I'll edit. We'll have salary 929, 2, 3, create should show up on the bottom. And I'll click the other edit button, the other plus button, S2. Okay. Now, I'm not seeing our graph. Right, so it makes me suspicious. Okay, but at least the list part works. And let's plug in and see if we can make this other thing work. I don't even know if outline group is okay with classes instead of structs. Okay. So content view. I'll plan list view. It's a new name. And he's going to have similarities. And actually, he's supposed to be a lot like this. All right, so this is plan.contents. Name. Plan.children. Well, name and children are okay. But yeah, so plan is using plan contents, which is the new approach. I don't know why that's not using contents. Okay. And plan list view. Yeah, something's funny, but okay. Take this one out. His contents come from the top level. Wait a minute. Plan.contents is the top level. Yeah. Okay. Content view. Right. So given the contents, get the header, and then make a group of its children or nothing. ID is name. Children is children. Okay, I guess that's okay. Yeah. Okay. Well, that looks a lot like the view down here. Yeah, we have a different view inside. Okay. Let's try it. Just slow. Okay. I'm confused. So that one shows it. Why is this other one not? Plan.contents. What's he going through? Plan.streams. Okay, so the streams apparently is right, and the contents and plan contents are wrong. Go figure. All right, let's test these now. Where are we on time? Okay. All right. Just a quick test. We just throw stuff at it, make sure it's appending stuff the right way and visible. Is it children? Well, he asks plan contents for the net of this month. Yeah, that seems okay to me. Children in content view. I I don't think so. Because the contents, the array gets the section name, and then we're going to its children for the first level. So the children of the My Finance node should be the children that we look at for the group. Contents has multiple lists. Yes. So it only has one, but it supports multiple. Maybe that's the way to say it. So contents has, wait a minute. Okay. Yeah. So I create one PlanTree, which is a plan composite, and I put that in the contents list. So it has the ability to have multiple plans, but right now we only have one in there. And that's kind of current behavior. So I'm okay with that, even though it has to kind of work a little harder to get to what's going on. Okay. So it takes the children of this, which defaults to nil, and so this creates a plan with nothing in it. Okay. And the hope was that doing the append would add a child, and in our case we're just adding a stream leaf. Okay. The array of children, is that what we loop over? Yes. So plancontents.net, we're talking to the plan contents to have it loop. Okay, so let's make sure that does actually run. Okay, so let's look here. Okay, I'm in editing mode. All right. So we didn't hit the breakpoint. Okay, so nobody's calling net. Well, that seems really weird, right? We know plan contents. Oh, wait. Yeah, plan contents is the sole item. Well, let's break here. Probably didn't need to rerun it. And I'm still going to try and say what this should be. I mean, that test looks like it. How is that test passing? Yeah, so, well, it's still starting up. What's weird to me is we had the graph showing before and the graph is not showing. So something's wrong somewhere. My fear is that we have the same problem that we had before, that things on the bottom change and doesn't get propagated up. Now, maybe I just had to say observable on my plan things. I don't know. I feel better if it would run. This is painful. All right. So, I mean, this in theory has to run because it's iterating over months. And we said project 12. Maybe I should run the tests and just check this one. Did I mean to rename net? No. I mean, we probably could. It might be total or something. But I don't mind net in a way. I mean, it is the net of all your incomes and expenses. Could probably inline that. Oh, mixed up now with project. Oh, project, yeah. Yeah, unfortunately, project and project share a spelling. This is supposed to be project. Oh, Am I stopped? Okay, I'm sitting here waiting because I'm stopped. All right, so now we got months. Cannot find months in scope. Well, how about month? Month 1. Okay. And let's step into plan contents. Observable plan. Okay. I guess I can step out of that. Step out of that. This is all the macro. Expands it to this before you ever. I mean, it's really the when you say observable, it inserts all these additional things where it detects what things have changed and stuff like that. All right, but I go back in. Okay, here's net for month. This is composite. Okay. And month better be 1 still. I can type. Okay. And then let's look at children. Nil. Okay, I guess that's true because we haven't added anything yet. We're first trying to display the whole thing empty. I'm going to take this break out momentarily, wherever it is. Don't need that one. I guess it's, well, I don't need this one either for now. Turn it off and continue. All right, that's the way it should be. Okay, and now I'm going to turn it on, hopefully not get all these spurious ones. Let's add a new salary. $100 starting in month 1, ending in month 3. I don't want to be here all day debugging. Weird. It does not. Who the heck is calling project? Content body.view. Oh, okay. All right, I may be misunderstanding, but I'm going to make, I don't know if I can make a protocol observable. Can I do this? No. Okay. Plan composite does not conform to plan 3. Why not? Plan leaf does not conform. Okay, let's query this. Well, that might be relevant. What if I take it off here? Okay, I'm calling plancontents.net. Now, my hope is that triggers it. Okay. Protocol observes it for add observable functions to protocol. Yes, I think probably I shouldn't do. I mean, I changed it and now we get notified, right? So before, when I did the add, the create, it didn't call this. So my suspicion is the fact that our tree changed, it did change, but it didn't get propagated. And I believe now it's getting propagated. So, because it didn't call net after the create before. All right, now I think I have another breakpoint maybe. Nope. Okay, so, oh, hey, look, S showed up. Okay, good. So now, yeah. All right, I'm feeling like, oh, good, climbed out of the hole. Okay, so we're seeing the graph because with the plan, the tree being observable, the fact that that changes, the plan finds out, the plan changes, and it updates and says, "Hey, I changed the net or project." That I changed, and you should rerun project basically. So we rerun it, and now we get the additional thing. Dollar month for 3 months. I'm not sure where the 120 months is how long we run that thing. Okay, so yeah, so we get $1 a month for 120 months. We're up to $120 basically. Okay. Yeah, so now I feel like, oh, if this worked, then we have a chance that this can go away because we've got something that builds off of our new thing. All right, so probably let's commit this. Make plan3 be observable, holds the tree we use to represent a plan. Okay. Now we haven't gotten rid of everything that uses the old school stuff. So we have all kinds of work to do. All right, but we'll take a break first. So 3 or 4 minutes, we'll come back. We'll strip out plan 2 because that wasn't working and we won't need it anymore. Then we'll see if we can swap in the view that we had before or some other variant of it, a new one probably. That is this, we had a stream view. We want to get that back in. Right now we're just printing the name. That's why it was just an S there. Okay. And once we have that, I think we'll verify these and then they don't look right to me, but we'll try these. Once those work, I mean, we'll mix in some tests with it as well and get this thing kind of together. All right, see you in a few minutes. All right, welcome back. Let's go back to our run. I think I still have it up. Yep. All right, so let's add another one. I'll do the other button just to prove that it doesn't matter. Tallery. And this is 3. Starts in 5, goes through 20. All right, it should show up in both. Okay. Right, now can I redo this? Oh, that just works. Oh, what? Sorry. So it changes it and it goes back. I'll try the other way. Boom. Okay. Yeah, so... All right, let's stop. Okay, so plan.contents.move. Plan.contents. So this is weird. Plan.contents.move should rearrange this. And I think maybe that's why it's going back, because it's taking it. Yeah, I think the index, let's get here. The index is being the index of the offset group item, like 0 or 1, but we only have a plans.contents sub 0. So I think it's trying to apply the offset of the children to the overall top level thing, and rearranging 1 to 0 does, it's sort of, there's only one thing in there. I'm not sure why the dragging up worked but dragging down doesn't. Maybe you're trying to drag to the offset 1, which is an invalid offset on contents, plan.contents. But yeah, this does not make sense for what it is. Now I don't know. I don't know if outline group actually handles on move like that. No, it's, I don't know if anybody else says outline group, just Apple. Okay. Not found. Okay, that's interesting. I really do want both. One link. Navigation stack and navigation link does not sound like outline group. Okay, supports hierarchical data with an outline group. Yes. Okay. And where's the other reference? Oh, that is the other reference. Okay. Okay. This looks more like an explanation of how to use this thing. A little not clear where he's getting these. Text item.name. Well, I don't know where he got the icons because I'd kind of like to have some icons, but I don't think he's given us enough information to see him. Image item.image. Okay. Oh, HStack. Yeah, that's kind of what we did. All right. Nothing about on move in here though. Nope. Okay. So I'm okay not being movable, but I got to be able to delete. Now delete. But what I think this is telling me is we can't do the system list level delete because again that is working at the wrong level. It wants to remove plan.contents, but down here it's removing, well, streamless view. No, let's get down to original. It's moving the streams, which is a simple array. So I don't think, I mean, what we're seeing is suggesting that there's no real way to do this in automatically for outline group. We certainly can't move the streams, right? Because the content view, are you thinking? Finished running. Yeah, so the streams are a simple array that you could reorganize. Now, I don't know if we can get to the children, but yeah. All right. I guess I can live without relocating items for now. I think we can probably work up something with drag and drop at some point. We'll probably have to do something kind of like what you were saying earlier, Mudshark666, about kind of navigating up and down the tree to do things that, like to delete something, you have to know the parent of it. And our tree structure does not maintain a parent relationship. It goes top down. You can do that. You can put that relationship in. It makes the tree more complicated, and I don't think it's necessarily any better. But if we need it, that's one thing. But on the other hand, if you set up your finance thing, I don't believe you're going to, I mean, nobody who has 150 accounts is going to use this, right? It's going to be small sets. I've got checking and I've got savings and I've got an IRA. My wife has one. Maybe I have a Roth and a regular, whatever. Yeah, I'm going to have a dozen accounts or 2 dozen accounts. I'm not going to have 200 accounts or 2,000 accounts or 2 million accounts. And if we're only talking 100 or so at most, walking down from the top of the tree to find the thing is not that hard. Okay. So, we can make it work. All right. But what that does tell me is these are not workable. Whoops. Okay. And that further tells me that the edit button is not workable. Okay. So let's run again. So we should see ++ edit because the original was editable. Yeah. All right. So all we've done is delete functions, so I'm not going to regret checking in. Now, I do think we do need to delete, but let's get everything else kind of reassembled into a good place before we try that. So maybe tomorrow we'll work on deleting, but I'm anticipating putting a little trash can icon on each row, on each stream, and let you click that and remove it from the thing. All right. Let's take out this unused thing now. So stream list view. All right, so that comes out, and let's take out that thing in here. Plan two. Net, all that. Okay. Make sure that runs tests. And the app should run. Okay. Yeah, so 3 times 3 years, $12 a month for 3 years. Looks like money. All right. So that. Okay. Right now, let's split this out. PlanTree. Well, I'm sure there's a better name for it. Maybe it's PlanTree. Test run. Okay. Okay, so let's add some tests. All right. So new file. His template's gotten a little outdated, but a PlanTree. Okay, you don't want this anymore. All right, let's put this PlanTree. A PlanTree. Okay, well, usually I do it this way. All right. So what I find easy to do with trees and kind of recursive structures, it's easier to start from the leaf. In my experience, if we trust the leaf, we get things terminating, and that's cool. All right, so let's test plan leaf. All right, and so we'll make one. First, we need a stream. All right, $100 income for life. And then we need a leaf. I think I'm going to be passing streams that are kind of obviously streams, so I'm going to take this out. Could be a couple more places will break from that. All right, so now we have a leaf. And we can ask its name. And that should be income. We can ask, well, I guess we can ask his children. And I tend to use that version of asserting. It's gonna tell me, oh, trees are not leaves are not equatable. Maybe I will assert nil. Hopefully it'll let me do that. All right. And then assert equal leaf.net for month 3 should be $100. Okay. And yeah, we'll just break this one just to make sure the test is building something real. Okay, so we kind of know it works because we've seen the name come out, so that part works at least. All right. Okay, and I think that's enough to check in. Maybe test is probably more accurate. All right, now the other one is more problematic. Okay, so composite, I mean, it's got the children, and we also have to make sure that all the children get dealt with. So I guess if I check the name, I guess I'm thinking of a tree that's kind of 2 level deep and put a couple children in there and make sure they sum up. Okay, so test plan composite. We may need more than one test. All right, so we're going to need a few streams, or at least a couple. Stream 1 is $1. Stream 2 is $2. Okay, so if we build let tree equal well, maybe I'll make this tree one. Okay, so if I make a plan composite top, or maybe I should say grandparent. It's the only parameter. I think it's going to be clear what it is. Oops. Probably plan uses it. suppose I can put the other order. And let's do parent dot append to our parent. Okay. And then grandparent. Okay. Tests like this require more setup. Let's see. So we got the trees. So it should look like grandparent goes to parent, goes to two kids. All right. And we need to ask, so we've done init, we can ask the name. Grandparent.name should be GP, which is what my kid's called. My wife's dad. Okay, and children is kind of implicit. Like I don't want to actually worry. Well, I guess I could ask. Grandparent dot children dot count should be 2. 1. Okay, and then okay, and we did append, but now let's do net. Grandparent.net for month 10 should be 3. That should be 2. Okay. So we put in 2 streams of income. And the net income should be the sum of those. All right. And I think we've basically used every function in this. So I don't feel like I have to build another structure. If this seems moderately complex and likely to catch if we screwed up net. I don't know, I can make it wrong. All right, and let's run this test. Okay. Net is screwed up, 0. So we're subtracting, we get 0. That's interesting. I thought we would get 1. Let's fix it. Maybe a bad sign. No. Okay, good. All right. So it goes down to the grandparent and grandchild level, adds those together, does the right thing. Okay. I guess I have one little twinge. Let's give the grandparent another child. plan leaf of stream of income 3, which is $3. All right, but I'm going to append that to tree 3. Okay, so now we should have 6 as our total income per month. The grandparent count should be 2, as should the parent count. Okay, and I don't think this will fail anymore. Then, I mean, I think it'll work just as well. But it gives us 2 kids at the top level that are, one's a leaf, one's an interior node, and that interior node has 2 more kids. So it builds up a moderately complicated situation. Usually, if you get the leaf right, you're sort of 90, maybe 80% there, and then get the corresponding functions that operate over the leaves. Okay. All right. Well, it's good to be able to trust this, at least better than we have. And also, I noticed I've got a pen working, and all that seems fine. So I'm moderately confident there. Let me close this. Let's go back to content view. Okay. So we miss on delete and on move, but other than that, the big thing we're not doing is we're not using stream view. Now, I think let's talk about, well, I think what we should be doing, part of the problem is we don't know if this thing is a top level, or I'm sorry, if it's a leaf or a composite. Right. If it's a leaf, we know it's a stream view, but it could be, if we had multiple levels, it wouldn't. So let's make an actual PlanTree view and let it sort out, am I looking at a stream or any of that stuff? Okay, so where's stream view? Is that in here? It's somewhere else. Okay. Well, let's see, stream view. Okay, so we're going to add PlanTree view, new file. Okay, and we want it to be a lot like stream view. Now, I don't know the best way to do maybe stream view is okay. All right, but PlanTree view is going to be given the tree. So this should be PlanTree type, right? Yeah. I'm not sure about the any. It's all right. So PlanTree view needs to be given var plan of PlanTree. Okay. Okay, not too generous, but oh well. All right, now plan is PlanTree. And this is plan composite, the tree. And we want PlanTree dot append plan leaf. Okay, so let's see, make sure this is previewable. Someday. Now, I don't actually know how to do this. I remember we did something like it at some point in sort tables, but let me search for this while it's thinking. All right, so Swift view depending on type. I don't know if I can just say if is, kind of thing. Yeah, I probably can make up my own conditional, right? Okay, there's hello world. Right. So if well, I kind of hate to do this. Springboard. Can I say type? I don't know if these are equivalent. PlanTree has no variable type. Does it have variable type? Oh, man. Okay. How about if plan is plan leaf? Do I say it like that? Oh, good. Okay. If it's plan leaf, I want to do a stream view. The stream is plan dot. Plan as plan leaf. Can I do this? Plan leaf dot stream. Okay, since I know it's a stream, a leaf, I know I can access stream. Okay, otherwise, text, well, it should be plan composite view of plan as plan composite. And we'll add a struct for that. Should be. Okay. So this thing should be displaying tree somewhere. There it is. Okay. Good, 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 good. All right. So now we've got something that sends us to either stream view or plan view. Well, maybe I'm going to make this struct stream. Let's see if, does that subview thing work on here? No. Rename this to plan leaf view. Okay. And now we want this in our content view. So instead of text of tree, PlanTree view, plan is tree. And I'm going to skip the colors for now. Okay, still good. All right. All right, so adding one of these should now add, it should now look like a simple name. This is my annuity. I wish. 30,000 a month. Let's be generous to me. Start month 10 and month 20. Now, I'm not so sure about that graph. It says I'm going to be $300 million from 10 months of this. That seems a little high. Okay, but at any rate, I'm seeing the stream view stuff, no coloring yet, but the appropriate thing for this annuity, just like here, it's the same view. Okay, so that's pretty good. All right, and at this point, I think I can take this second view out. I think we've covered it modulo editing and modulo, moving and deleting. All right. So let's take that. Well, let's check it in like this. Add PlanTree view that calls either plan leaf view or plan composite view. All right. Now, at some point, I might want stream to merge in, but I think in reality, I suspect there are going to be more leaf types. And so plan leaf can dispatch whatever it is. We'll make a pattern that dispatches to each individual one. And at that point, I think plan leaf will probably become plan stream, and there will be a plan pool or plan, I don't know what. I guess pool and stream are my metaphor, so I'll stick with pool. But there'll be a plan pool that also is kind of a leaf node. Alrighty, let's clean this up. So now we're only going to show plan list view. We're committing to our new approach. Plan list view, and the stream original goes away. And let's extract this into plan list view. New file. Oh, and we haven't created one yet. Okay, that's probably addressable. Okay, so this thing takes a plan. Okay, so we'll make a new plan. What else do we need for a plan? Well, he starts with one, and he doesn't really show a name. Let's just add a stream. Plant contents depend. Yeah. Do we need to make PlanTree observable? Only when we update the leaves that we need to do a new projection. Yeah, I think it is there to do that because we do consult plan in our view. So I would think, I haven't done much with observable, but my understanding is it goes through the view and says, what are the fields you access from this object? And the content view says, I got to ask the plan for something, and so it puts in the observers on the stuff that can affect that. So I think it does. I might be wrong. It might be enough that it contains something that does, but think we can, well, let me check this in. Let's see. I guess we want to run with it. Plan Swift view is in referenced by content view. Plan last view of plan. Okay. Yeah. So let's make a run. Yeah, I think he's overly generous. I don't think 200,000 a month, $200 a month for basically 3 years. That's 2,400 a month. That should not be 20 something thousand dollars. 30. Yeah, something's off. Okay, but the finances with the stuff in it, it's working, working as it does so far. All right, so let's commit this. Extract plan list view to a separate file. Okay, and then let's do the experiment. We just have a couple minutes, so let's take plan, remove observable, and see if it all works. I might leave. Oh, here we go. Yeah, we can't bind to it. Yeah, bindable comes from observable. Yep. Okay. So whether every intermediate thing, if you had intermediate classes, you might not need it. I don't know. Well, actually, we do, because we have an array of observables, so it must be accommodating that. Probably they have some way, because they detect types and stuff. I think they probably say, "Gee, we need to be able to make observables work on arrays." That was one of the kind of limitations you had before. Arrays and optionals didn't work so well, and they've explicitly managed those. So I'm not sure if that's the full case. All right, let's make sure everything's green. Okay, so well, let's see what all we did here. We tested our enum-based tree and found it didn't propagate info properly. Tried, I guess I could say spiked a struct version that had a similar problem. No, I guess the struct version, the problem was that didn't handle leaf types different from the interior nodes. Then we developed PlanTree, a class-based tree. We made UI work with PlanTree. I guess we also removed the unsuccessful enum interface. Made UI work with PlanTree. I think that's where we are. Oh, well, we added tests. Well, including backfilled tests. All right, so this, we haven't done alternatives yet. All right, move streams between sections, edit stream. Well, we want to move streams, delete streams, and moving between sections is much later. End date greater than start date, or at least greater than or equal to. We'll have to check. Okay. Yeah. So, I mean, I'm glad to be through this. It was a little fraught. I definitely felt so much more relaxed after we got the class version working, because I was worried enum-based would fall apart later on. But we are set up for alternative scenarios at this point. Well, actually, no. I think what we'll do first is we'll add multiple sections. Okay, so that wasn't in our original UI, but I do want that scenario section separate from the baseline and so on. So I think having the multiple sections will be a good thing. And I want to push through to the scenario alternatives, because that has to generate combinations of things. And once we have those combinations and we can compare them, that really is kind of a fundamental thing I want out of this. So pushing those through, even though the interface and all is still a little clunky for it, I think will be a good place. Yeah, I think that's it. We know most things are possible at this point. The biggest risk is, can we deal with the and or trees? I think there's a secondary risk of making an interface that is comprehensible based on that, because it's a little understanding trees and outlines is a little bit of a skill. And then there's going to be plenty of other things coming down, but getting the scenarios in even a primitive form. We talk about water through the pipes on something. So get something that kind of cuts across your whole architecture. And I mean, architecturally, we're not doing anything different, but, kind of in the same mode of across the whole design, that we kind of touch, areas touch all the different areas a little bit. We did a little graphing, a little bit of stream stuff, and now we'll do the alternatives. Those three things are kind of core to what we're doing. So having that in place will reassure us that the rest is just, simple matter of programming kind of thing. It'll be more, but that's okay. All right. Well, thanks for coming along for the journey today. I'm glad we got where we got. I'm hoping this stands up well when we start adding the flows and the people and the other things, and stands up well for alternatives. And we'll find out tomorrow, at least starting tomorrow, 2 to 4:30 Eastern, 6 to 8:30 p.m. UTC. And thanks again, and have a good night. Bye-bye.